Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 156, maximum rated KH path. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I think this one's a little bit weird, a little bit tricky. It is a medium, which is a little bit weird. There's a lot of things weird about this one. But yeah, let me start by, I'm going to show you my code, but actually I don't want to explain it in that way. Yeah, let me start by kind of writing the dynamic programming version, right? Which I kind of started doing the contest, but I didn't ultimately write it that way. But spoiler alert. But yeah, I think the idea here is that okay, let's say we have right, we have a node, we have k left, and we have t left, right? So that'll be our dynamic programming. So the way that I would think about that is that I would have someone like that, right? And then yeah. Right? And the way that I would think about it is just that yeah, and then you kind of write out the dynamic programming in that way, right? So here, if k left is equal to 0, then this is where you get the best results, right? So maybe we have a thing, and the cache we don't. Maybe it's fine. I don't know, right? So then here, if k left is equal to 0, and cache is just so that you don't revisit it. I don't think it really matters what you return, honestly, which is kind of a weird way. So maybe it's not really dynamic programming, but almost like a depth first search type thing, right? So we have a best, right, is equal to, say, -1. So if k left is equal to 0, we know that t left has to be 0 or has to be actually greater than 0, right? Because it has to be strictly less than t. So that means that, yeah, if t, so then t minus t left is going to be how much you used. So then best, we can just do best is equal to max of best this, right? Non-local best. And that's basically the idea. And we return, like I said, this is going to be a depth first search type dynamic programming, where now we just go for v in ye of node. Then now if v is not equal to parent, we should actually add a parent. But the parent doesn't really change anything, right? Because the parent is uniquely determined by node, because this is rooted at 0 and you're only going in one direction, right? And then now if parent is not equal to node, then we have go, what is it? Go v node to update the parent, k left -1, right? And then t left minus, oh, we have to wait here. So wait. And I'm going a little bit fast. I set up the DAG by just converting U, V, and W into an adjacency list. I think that's the only other context that you need. But yeah, but that's basically going to be the key part here, is that I just visit this, and then that's it, right? We don't even care about the return result because it doesn't matter. We just kind of visit all the things, right? And then we can return best after we started from go 0. Parent is -1, sorry, k and t, right? And then we could, hopefully this is good. 3, 3, 6, 3, 2, -1. So that's no good, no bueno. We also want to say, I don't check. That's why. So if t, we also should always check if t left is then we return, right? Okay. I don't know. We talked about it, but I missed it. Okay, so 3, 2, -1, right? So then now we can, try to submit, right? Okay. Let's actually get this basic one right first. I don't know. I'm messing up a lot. Maybe I'm going a little bit fast. My apologies, right? So yeah. Oh. No, that's fine. Yeah. No, I was just trying to think whether I was off by 1 on the K. But yeah. 1 and 5, 11. The answer is 8. They said that the answer should be 9. Because it goes from 1 to 2. Oh, I'm dumb. I must have confused this with Q4. Sorry. There's no root, right? So then now we have to try for each node. So right. Yeah. And we don't have to. So I am confusing this with the other part because there's no parent because this is a DAG, so we don't go up anyway. I am sorry, friends. I am confusing a lot of things. But yeah, we don't need parent. We don't need this check, right? It looks okay. Okay, yeah. Okay. So apparently this is good enough. So maybe that's why the medium is good. But the reason why this is Okay, I don't know what to say anymore. But yeah, node can go from 0 to n, right? K left clearly is 300 up to 300. T left is up to 600. So then now this kind of multiplies out to be pretty big, especially since you have a for loop. Though the for loop, it's actually you can replace. The thing is that there's this node thing where you can say, okay, well, there are a lot of edges, but not all the edges visit all the same thing. So that means that the complexity of node is actually it's not the number of edges per input, right? It is the summation of all the nodes edges connection is the edges. So therefore, technically, this part is just going to be the number of edges times k left times t right, right? That's gonna be so. It gets amortized, right? Because basically you want to sum up total number of edges. It's gonna be equal to the total number of cores, or rather per node, right? Because the total number of edges is the total number of cores with nodes, maybe, right? So another way to think about this is, let's say we ignore k left and t left, right? Then what would become complexity? Well, if we ignore these two, then the complexity would be O of the number of edges, right? V plus E, because we only look at each edge once and we don't look at each node once, so it's going to be V plus E. So adding k left and t left is just exactly the same thing, is that for each node, it's V plus E times k left times t left, right? So then now this is like maybe 300, maybe you say even plus 300 if you want to be more pedantic about it. But however, that is actually kind of big, is 108 million, right? So why does this work? The TLDR is why it works is just because a lot of them are not possible, right? Yeah, I mean T is 600, but it actually isn't even 600. No, I guess it could be, but a lot of them are just not possible. I think that's the TLDR, right? And because a lot of them are not possible, then you just kind of end up going faster. For example, like if node is the root node, or not a root node, but if you look at it as these things, if 0 is your root node, then k left cannot be like k. Okay, let's say in a really bad case, you have a linked list, right? So you have like 0 looking at 1, looking at 2, looking at 3, and you can also even draw edges from 0 to 2, 0 to 3, dot dot dot. So it's like a full graph, but I didn't draw it that way, right? Then now, but keep in mind that if node is 0, k left always has to be k, right? Because after one move, it's not possible to be at 0 anymore, right? So that already eliminates a lot of possibilities on the T left side as well, because, so you can kind of think of it that way as why it is fast enough, but honestly, it's a really weird proof to kind of be able to get. But yeah, once you kind of realize this though, and I was trying to get something like, or honestly, I did write something similar to this, but then I didn't think that it was going to be fast enough. Because at this point I knew, but I just wasn't sure that I just didn't think it was fast enough. So then the way that I talked about this specifically is that it is a DFS, right? So what I thought was that, okay, well, maybe I could just do a BFS. And that's really the idea behind this. My second thing is that, okay, I have a BFS. I start at Yeah, maybe I'll rewrite this actually, because the way that I end up writing this is using bitmask because I wasn't super confident about it, but maybe that yeah, maybe I didn't need to use bitmask. Maybe it's good enough without it, right? So actually, let me real. This is a lot of upsolving today. Yeah, Q3 is it? So yeah, so then now we will try to do it with breadth first search, right? So breadth first search, what would that look like? Yeah, so then now here we just want to keep the set of and right, and this is basically saying that okay, well, for each one after zero distances, set 0 is possible. You can get to 0 distance, right? And then new distances, we would also write just set for right? And then now for every one of these, we go okay. Well, for k in distances of I, so k. Oh no, I shouldn't use k. Sorry. Let's say pd for previous distance, right? So this is the previous distance. Then now new distances of we want to add the PD plus W, right? Assuming that PD plus W is less than T strictly, say, right? And that's it. So yeah, if C in distances of I, and this part maybe you could just also put this as part of the if statement, but I'll just leave it here for symmetry reasons. Set is not iterable. Oh yeah. Right. So 3, 2, 1. I don't know if it's fast enough though. So we'll see. Yeah, and apparently it is fast enough. So yeah. And that's it. That's the BFS one. Is that saying that okay? Well. Yeah. So this is the part where it is at length 0, right? So that means that distances sub I is equal to the set of possible distances reaching node I, right? And at the beginning it's going to be 0, and then we want to iterate k times, and you could kind of think of this as like a space optimization thing, though I didn't think of it explicitly. Is that okay? Well, we set a new distances is equal to an empty set because nothing is possible, and it's only possible if we're relaxing I, and when we're relaxing I, we go okay. Well, the previous distance of I, maybe I don't know if it's easier to think of it this way, right? So that means that for every distance, we look at every edge, and then we just combine them, right? And then that will give us this number, right? As long as it's less than T. And here, maybe now would be the time for the max is equal to -1, and then we can just return best. And then here, we can say best is equal to max best PD plus W, right? So we can write that just to get rid of the 2 loops. But, ooh, huh. Oh, the reason why is because for 0 we don't keep track of this one. But I think the idea is right? So I guess maybe this is a loop because the K loop is 0. So also this is just wrong. Oh, sorry. Because you have to do it at exactly distances, right? So I'm wrong on this one. Sorry. So for I in range of n, I don't know why I thought that. So okay, so I'm wrong. We just go best is equal to max best max of distances of I, right? So something like that is fine because you have to be exactly yeah, okay, and it has to be -1, I think. No, it's what do I call it? Default value. I forget what it's called. Empty. I forget what it's called though. But fine, we can just add an if statement anyway. If length of distances of I is greater than 0, right? Yeah. Maybe I should check that one. But yeah, but that's it, right? So this one you can think of it more of a BFS, right? is that we have a set, we convert it to a set, and then we have new distances for almost like a BFS, one distance away, right? And we start at all of them simultaneously. And then now the thing that I did do during the contest actually, even though it's a little bit awkward now, is that yeah, is that then I just I mean, I actually wasn't sure that this would be fast enough to be frank, so I kind of converted to using bit set. That's what I did here. So one means that on the 0th bit is true, and new distance is 0 in all of them, and then this is the shift and or. So yeah, is this great? I don't know. Let's take a look at. I'll give it a submit just so that I have a that I could look at the complexity time. But here, clearly you don't need to know it for this one, so maybe that's why this one is a medium. But yeah. Yeah, so this actually ended up being slower because you have to do like crazy mod operations. So maybe that's why. Not quite sure, to be frank. But yeah. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah. Uh, yeah. You can watch me solve it live in the contest now. Oh, okay. That one's kind of hard to work out. I don't know how so many people got it so fast. Good job, people. Okay, rubber dag represented by 2D array edges. UVW, you're given 2 integers K and T. Your task is doing the maximum possible sum of edge weights for what? Okay. 2 integers K and T. You want a path of exactly K edges, and the total sum of the edge is strictly less than T. Return the maximum possible sum, which is less than T strictly. Okay, so if T is equal to 4, then on 3. It is a DAG, so there's no cycle, so you can. Okay. And we're given the K ahead of time, so that's nice. The number of edges, okay. I mean, that means that we probably could do some DP thing. Wow, N is 300. What does that mean? T is, what is T again? 600. So maybe we have to do DP on that. What's K again? K is the number of edges. I mean, it's DP. I don't know. I don't know. I want to write it down. Okay, so you have a current node. You have the number of edges used, and then you have T. I mean, that's gonna be too expensive, right? 300, 300, 600 is definitely way too expensive, right? Weights of I is 10 is maybe interesting, but maybe not. I don't know. Let's actually convert that first. Okay, right? It's it's a DAG. I mean, you could kind of root it and then everything else is just a difference. So you don't have to calculate from each node, which cuts off a lot of research. But this is definitely. I mean, this would be the naive thing, but that's definitely also way too big. Right? Okay, I mean the 300 nodes, 300k. That means that at worst you should be able to do 300 to 300. So that means that for every node we should be able to get all the nodes. Is that right? Oh. So we can't do a buffer search from every node. I mean, it's still like delta thing, but thought it'd be DP, but I don't. Maybe it's not. Can I do a delta thing? Not exactly, I suppose. It has to be in the path. Okay, so let's say we do a search, right? But that, okay. Huh. Mm, 54 million is definitely too big. Hmm. Can I do them simultaneously? Okay, so you start 300, you do one move each. Not like bottoms up, right? And you do all the K at the same time. The T is. Do we want to max it? Well, I guess that's the tricky part, is that it's not a min on the weights. So that's not quite how you would do a buffer search type thing on the M and the K. The node and the K. I mean, unless it is like another bit set thing. Which I really hope it doesn't, because that's kind of lame. It is a DAG, so it will all progress. Let's give it a YOLO try. Okay, so what are we doing? Let's go at distances. Right. No, we can. Oh yeah. We're doing the bitmask thing, bitwise thing. Okay, fine. So then now it's actually all 1 because they are at 0 bits. Okay, that is confusing, but okay, fine. Right. So then now we go. Okay, so then now we run k times, maybe k plus 1 times, I don't know. No, so it's the number of edges. So if we run it 1 time, it's going to be 1 edge. So I think that's fine, right? So then now for I in range of n, and then now for let me tell for each time we do this, we actually just run, I mean, O of n plus e, so 600 plus. Okay, maybe that's fine. In E sub I VW. Let's just say new distances. No, I mean it's fine, right? So distances, possible distances. No, what do new distances say? Right? New distances of we, because we travel to we, is equal to or shift by the distances sub I shift by W, right? Are we going to do bit set something like that? Because it's all the way that you can get there and then W. Okay, fine. Right? And then distances is equal to new distances. Alright, does this even run? There's like some weird thing with mods and stuff, but okay, fine, right? So then now, how do I even get like the most significant bit without doing, I guess 600 times 300 is not that bad, right? This is so silly though. I probably want to mod, but okay, fine. Right? Something like this. -1, I guess. And then now, okay, maybe I actually want it the other way. So for C in range of T minus 1 if for I in range of N, otherwise we return -1. If distances of I return C, something like that. Is it fast enough? I don't know. 320, am I right? Okay. YOLO submit. I wouldn't be surprised if this times out. It's very YOLO. Okay, well, this is actually slightly more surprising. 22. That's weird though. Should be zeroed out. That's definitely not what I would expect. Actually, 66. From 0 to 1 with a rate of 3. So that's how you get to 8. And we want 22 steps or something. So that definitely shouldn't be right. Distances of we. Oh, why did well, it's a DAG, Larry. It's a DAG. It's a DAG. That's so dumb. Okay, well, I don't know what I'm thinking. I gotta stop doing that on autopilot on the DAG. So I write this like on autopilot, and so like I think that's why. Okay, I mean that's just a way. I don't know if I like that problem. It's a very weird problem. I don't know if you could do it without bit set or whatever, but I guess I'm not gonna find out until. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me in Discord. Let me know what you think about this contest, this video, this problem, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.